Here I have another second order differential equation. We start by solving the characteristic equation, r squared plus 4r plus 4 equal to 0. If we factor this, we get r plus 2 squared equal to 0. So my values of r, this time I have one repeated solution. In this case, I have c1 e to the rt. And whenever I talked about systems and I had these repeated roots, I added in a factor of t, and that's what I need to do here as well. c2t e to the minus 2t. Since our initial conditions also deal with the derivative, we need to take the derivative. We get minus 2c1 e to the minus 2t. And here we need to use the product rule. The derivative of the first times the second plus the first times derivative of the second. We know that when we stick in 1, or when we stick in 0, our equation will be equal to 1. So that's c1 times e to the 0 plus c2 times 0 times e to the 0. So we just have 1 is equal to c1 from my first equation. We know the derivative is equal to 3 whenever I stick in 0. So it's minus 2c1 times e to the 0 plus c2 times e to the 0 plus 0. We already know what c2 is, or c1 is. It's 1. Adding 2 to both sides gives me 5. So that tells me that my general solution here is of the form e to the minus 2t plus 5t e to the minus 2t.